Welcome to this explainer. When we look at a sleek, lightning-fast web app, it's super easy to forget about the hidden, almost entirely invisible factory floor running behind the scenes. We're going to open the doors to that factory today and examine the incredible tools that actually make the modern web possible. Let's dive right in.
Seriously, think about this for a second. How exactly does a developer's messy, raw code magically transform into a blazing fast website? Modern Developer Experience, or DX, is all about readability and high-level abstraction, but that inherently creates a massive gap with the lean, highly optimized execution environments that browsers actually require. Browsers don't care about modern shorthand or human-readable architecture. They want foolproof, optimized instructions. Bridging this gap is the core problem we're solving today, and it takes some heavy manufacturing to get right.
So here is the roadmap for our factory tour. 1. The code assembly line. 2. Quality control. 3. The universal translator. 4. Heavy machinery. 5. The speed daemon. And 6. Securing environment variables. Let's get moving.
Station 1. The code assembly line. From raw code to polished product.
Make no mistake, modern web development is a factory. It's a highly structured pipeline. Think of your raw code like raw timber or unrefined steel. In its natural state, it has tons of potential, but it is completely unready for a production environment. Processing this material involves things like module resolution, minification, and polyfilling. If you just shipped raw code directly, it would break on legacy engines, it would suffer from bloated load times, and it would expose massive architectural risks. Build tools act as the mechanized assembly line, bridging that critical gap between developer and production environments.
Moving on to Station 2, Quality Control, specifically ESLint and Prettier. Now, two very different types of quality control have to happen before your code ever goes live. Both of these tools parse your code into abstract syntax trees, or ASTs, but they use them for totally different reasons. ESLint is basically your structural safety inspector. It traverses the AST, analyzing logic paths to catch actual bugs, broken rules, and fatal errors, like, say, an unused variable or an infinite loop. Prettier, on the other hand, doesn't care about your logic at all. It acts as an obsessive proofreader, taking that AST and just reprinting it from scratch with perfectly standardized formatting. So the takeaway here is that ESLint ensures the code executes safely, while Prettier enforces visual consistency across the whole codebase.
Next up, Station 3. The Universal Translator Babel.
So what happens when a user tries to visit your cutting-edge app using a browser from, 5 years ago? JavaScript is constantly evolving, right? And developers naturally want to use the absolute latest ES6+ features for better architecture. But those older legacy engines, they will simply crash when they hit unknown syntax. This is exactly where a transpiler like Babel steps in. It takes that futuristic next-gen JavaScript and transpiles it backwards into a broadly compatible version, injecting polyfills where necessary to literally recreate missing features. Essentially, you get to write code in the future, while Babel ensures it runs flawlessly in the past.
Which brings us to Station 4, Heavy Machinery. Let's talk Webpack basics.
All right, so your code is checked and it's transpiled, but now you're left with a massive, tangled web of individual JavaScript, CSS, and asset files. Enter Webpack. This is the reliable, classic heavy machinery of the web development world. Webpack crawls your application's entry point to map out a complete dependency graph. It figures out exactly how every single module, style sheet, and image relates to one another, and then it statically compiles them. It crushes hundreds of dependencies down into just one or two highly optimized bundles, aggressively minimizing HTTP requests to ensure maximum efficiency in the browser.
But things are changing fast, which leads us to Station 5, the speed daemon, Vite.
There is a massive generational shift happening right now on the factory floor regarding how this bundling is handled. With classic tools like Webpack, the bundler has to rebuild the entire dependency graph every single time a developer hits save. That is a heavy-duty process that can take several seconds or literally minutes on large projects. Vite, which is actually French for fast, completely flips this model on its head. Instead of bundling everything up front, Vite leverages native ES modules, or ESM, directly in the browser to serve files on demand. When you make a change, it uses hot module replacement, or HMR, to update only the specific module that changed. It is the difference between a slow-moving freight train and a sleek bullet train, making the developer's experience virtually instantaneous.
Finally, our last stop, Station 6, Securing Environment Variables, also known as the Vault.
Listen, modern web applications absolutely require secret information to function. We're talking database passwords, hidden API keys, internal routing URLs. You simply cannot write these secrets directly into your application code. This station is all about build time injection. These secrets are kept locally in hidden.env files. During the assembly process, your build tools read these hidden variables and safely inject them into the code via global constants, like process.env, based on whether you're in a safe testing mode or a live production mode. This is absolutely crucial because it ensures that sensitive keys never make it into the client-side bundle, preventing them from being broadcast to the entire public internet.
Okay, let's take a step back and look at the whole shebang. We've zoomed in on these tools individually, but here is the actual chronological flow of our code assembly line. Step 1, write and format, where Prettier instantly standardizes the AST. Step 2, lint, as ESLint traverses the logic paths, hunting for bugs. Step 3, transpile, with Babel transforming modern syntax into backward-compatible code. And Step 4, bundle, where heavy machinery like Webpack or Vite resolves the dependency graph into a sleek, optimized package ready for the world. Every single time a developer pushes code, this incredible mechanized dance happens behind the scenes. Which leaves us with this final thought. We've seen the evolution from the methodical, static compilation of Webpack to the lightning-fast, native ESM architecture of Vite. The JavaScript ecosystem is famous for its relentless, breakneck pace of innovation. What you should really take away from this explainer is that this invisible factory floor is always upgrading. So, with tools evolving this fast, what is the assembly line going to look like tomorrow? Will bundling even exist in 5 years? Or will browsers evolve to handle raw code entirely natively? It's an absolutely fascinating space to watch. Thank you so much for joining me on this tour today, and keep exploring.